Hi all, this is Elim Kiganjani. Welcome to another mathematics session. In this session, we're going to continue with the topic of trigonometry from 5 content. Last video we covered introduction part, and in this part we are going to continue with trigonometric identities. And talking of identities, I'd like actually to show you the identities we'll be talking on in this session, and these identities we are going to see together how we prove actually that cos square theta plus sine square theta equals to 1. The second one being sec square theta equals to 1 plus tan square theta, and the third one being cosec square theta equals to 1 plus cot square theta. So these are the 3 identities we are going to derive, and after that we are going to see some questions. So before we start these identities, I just want to remind you what we covered yesterday, because in yesterday's coverage we had derived actually, or we have seen 6 different trigonometric ratio identities, and I'm going to refer to this triangle here. So with this triangle being given, if this side is A and this is B and hypotenuse is C, I'll be talking that sine theta is opposite side, which is A over C. Cosine theta adjacent side over hypotenuse, and that is B over C. While tan theta is opposite of adjacent side, which is A over B. And talking of the corresponding reciprocals, with their corresponding reciprocals, 1 over sine theta, this is cosecant theta, and this is the reciprocal of sine theta, which is C over A. And 1 over cosine theta, this is actually sec theta, and the reciprocal of cosine theta is going to be C over B. And talking of reciprocal of tan theta, that is 1 over tan theta, this will be equal to actually B over A, dear students, but that is actually cot theta. So this is cot theta, and it's going to be B over A. So we have seen that these are the basic trigonometric ratios, and the reciprocals we have seen the name corresponding to them. So with the recap of yesterday, now let us start trigonometric identities. And the trigonometric identities, the basic one I'll be starting with is proving the first formula here, that sine square theta plus cosine square theta equals to 1. By using Pythagoras theorem from this triangle, I could say that by using Pythagoras theorem, we can easily see that x square plus y square equals to r square. So we'll be dividing by r square both sides. so that you have x square over r square plus y square over r square equals to r square over r square. This will be x over r square plus y over r square equals to 1. And checking the ratios, x over r is cosine theta, and y over r equals to sine theta. So we can easily see the connection now here, that x over r is cos theta square plus y over r, and y over r you have actually sine theta square, eventually you have 1. So you can easily see the first trigonometric identity derived here is cosine square theta plus sine square theta. The result is going to be equal to 1. So that is the result for the first identity, and it is one of the very important actually identity to be remembered and to be used in most of the questions. So by using the first identity, we are going to derive the other identities. So you can note this as identity number 1. So noting that is identity number 1, I'll be taking now identity number 1, that is cos square theta plus sine square theta equals to 1. And I could tell you that divide by cos square theta throughout the equation. When you do that, we will be getting actually cos square theta over cos square theta plus sine square theta over cos square theta equals to 1 over cos square theta. When you see this, you have now 1 plus sine theta over cosine theta square, and this is going to be 1 over cosine theta square, yes students. And we know sine theta over cosine theta is tan theta. So this is tan theta already, and this is sec theta, of course. So from this expression, we'll be seeing that 1 or plus tan square theta, this will be equal to sec square theta. So this is the second identity, which is again very important to be remembered, because this identity again will be used in so many other different areas. Coming to the third identity, we are going to use actually the same we are going to use the same identity, the original one we derived before. I'll be saying that again, from cos square theta plus sine square theta equals to 1, I'll say divide by sine theta throughout. So when we divide by sine theta throughout, we'll be having now cos square theta over sine square theta plus sine square theta over sine square theta. Eventually be having 1 over sine square theta. With normal division now, you'll be having cos theta over sine theta, that is square, plus 1 equals to 1 over sine theta square. So we have seen this identity, and we remember that this was actually cot theta, and this is cosec. So the identity to come from this one here is cot square theta plus 1 equals to cosec square theta. And this is the third identity. This is actually third identity we are using, and this is gonna be one of the identities to be used in most of the questions in this topic, dear students. So we managed to derive the important three identities. The first one being this identity here. The second identity is here, and the third identity is here, dear students. So with those identities, let us see now how the questions are coming. Let us see how the questions are coming. So the first question in our discussion is simplify sine theta plus cos theta cot theta. So this solution, so this is equal to this is basically equal to sine theta plus cosine theta times, mind you, cot theta is cosine theta again divided by sine theta. So that is going to be equal to, you put in a common denominator, so you have sine theta, and here you'll be having sine squared theta now plus cos squared theta. But sine squared theta plus cos squared theta equals to 1, and so we'll be having actually 1 over sine theta, and that is going to be cosec theta, hence simplified. So that is a simplified expression from the given question above, dear students. Let us go to the second question. If x equals to sine theta, then show that x over square root of 1 minus x squared equals to tan theta. So to solve this question, you can actually decide to go from any side. I will prefer to start with left hand side. So I can say from left hand side, you have x over square root of 1 minus x squared. This is going to be equal to sine theta over square root of 1 minus sine squared theta. And 1 minus sine squared theta, 1 minus sine squared theta, this is actually cos squared theta. So basically, you'll be having sine theta over square root of cos squared theta. So taking the square root, we'll be having sine theta over cosine theta, and this is actually equal to tan theta. So you can just conclude that we have already actually shown that tan theta is equal to xc over square root of 1 minus x square, and this is actually a right hand side expression, dear students. Jumping to question number 3. Solve the equation 2 sine square theta minus 1 equals to cosine theta for values of theta between 0 and 360. So we take in this question 2 sine square theta minus 1 equals to cosine theta. But from sine square theta plus cos square theta equals to 1, we can make sine square theta the subject. So sine square theta can be replaced by 1 minus cosine square theta, so that this expression will be 2 sine square theta, that is 1 minus cos square theta minus 1 again equals to cosine theta. You open the bracket, we'll be having 2 minus 2 cos square theta minus 1 equals to cosine theta. You collect like terms, you'll be having actually 2 cos square theta plus cosine theta, 2 minus 1, so minus 1 if will be taken to the other side, of course. And with this, you can solve actually by factorization method. It is actually 2 cosine theta minus 2, plus 2 cosine theta minus cos theta minus 1 equals to 0. So 2 cosine theta been taken out of the bracket. We'll be having, this was square, of course. We'll be having now cosine theta plus 1 minus 1 cosine theta plus 1 equals to 0. So as we proceed solving the question, dear students, so you can see that now the equation is reduced into factors 2 cos theta minus 1, then you have cosine theta plus 1 equals to 0. So we can easily say now 2 cos theta minus 1 equals to 0, or cos theta plus 1 equals to 0. With this being said, cos theta now will be 1 over 2, or cosine theta equals to a half. So remembering, an apology, or equal to negative a half, negative 1, sorry. Remember the values, we were told that actually angles are between 0 and 360. So I just want to remind you on 4 quadrant and the sign of trigonometric ratios. So cosine, sine, tangent, here positive, positive, positive. But here cosine is negative, tangent is negative, and sine is positive, of course. The third one, sine negative, cosine is negative, while tan is positive, of course. The fourth quadrant, we are going this way, of course. So here sine is negative, cosine is positive, while tangent is negative. So with these details in our hand now, having cos theta equals to a half, of course theta, you'll be taking cos inverse of a half, which is the first angle is going to be 60. But we know that cosine is positive not only in the first quadrant, but even the last quadrant. So it means the other angle will be 360 minus 60. So it will be actually 300. So it means we have 300 degrees and we have 60 degree. Coming to cos theta equals to -1, mind you, it is either 0 or 180, so here theta will be 180 degrees. So combining the two solutions, we're going to conclude that therefore theta is 60, 180 degree, or 300 degrees, dear students. So that is solution for this question here, question number question number 3.